what is sustainable OpenFOAM development. And I'm going to spoil the surprise because I'm going to answer it immediately. I think it's important to create a definition for these things. And I put together a definition which sort of comes out of sustainability in general. So I'm using phrases and words from that. And I think this is a good definition. It's developing software that meets critical needs of the users through a balance of resources, technology, investment, and institutional support. And there are two parts to that. There's critical needs of the users, and then there's this balance of resources and so on. This morning's talks are going to be devoted to those critical needs. I'm going to start by explaining what they are and the work involved to deliver those needs, and then other presenters will talk in more detail about how that happens. The afternoon will start to move the conversation more towards the balance of resources, and we'll finish off focusing completely on that part. And then I think we'll have an understanding then of sustainable development. So let's start with the critical needs. OpenFOAM is complex. It's got it's a huge bit of software with lots of libraries, core libraries with algebra, numerics, geometry manipulation, parallelization, and so on. And people build these model libraries with fluid dynamics models, thermodynamics models, chemistry, etc. And again, more talks on that later. From that, people then build applications, CFD solvers, meshing tools, initialization tools, visualization. And people use it by setting up cases, and there are cases, and OpenFOAM has a file-based setup, and there are lots of examples, there are templates, there are example geometries. It also relies on other bits of software, so that you have to compile this thing, so we rely on compilers. There are parallelization libraries, so the Scotch library. We've got visualization software we rely on, and then underneath it all, it's all this documentation. So I would say that is OpenFOAM. In short, right, it's 1.5 million lines of C++ code. You've got 250 of these applications. You've got 250 examples. And I've added a layer in here which is talking about some of the work, some of the other things that are needed, distribution, how we get this to people, source guide, documentation, third-party software. So it's a big thing. And it's free. So that's the thing we're offering here. We provide this thing for free. What people do with it is that they, first of all, extend the current set of simulations by building their own solutions, so they create their own CFD solutions. They create new applications, extending on the existing ones typically, and then they customize libraries they add on top of the libraries. And so that's what you, the users, are doing with the software. And you need then, overall, certain things. The one that's most overlooked is availability. Can I get the software? Where do I get it from? How do I get it? How do I know it's there? All that sort of stuff. So that's the first critical need, availability. Second thing is, can I use it sensibly? So there's usability. Third thing you need is robustness. If I have set it up sensibly, does it deliver reliable solutions? And the thing which is the icing on the cake, which I think open source offers far greater benefit from, is extensibility. Can I add my own models to the library set? And so when we talk about the critical needs in that definition of sustainable software, we're talking about those four things. And to deliver those four things, work has to be done. And if those needs are critical, the work is also critical. And the work that needs to be done, you can break down into three areas. What I call publishing, repair, and redesign. And just for a point here, I would say repair is most closely linked to robustness, but the other two, certainly redesign covers all of those things, and publishing to an extent also covers those things as well. It relates to those things. So if we're going to get sustainability right, we're going to meet the critical needs of you, the user, then we need to talk about the critical work, and that's what I'm going to talk about now. So publishing, what do we mean? Code gets written. We publish code. It is available in the OpenFOAM repository on GitHub. There's availability straight away. The repository is split into two branches. There's the release version, which contains or is updated with bug fixes, and then there's the OpenFOAM dev, the development version, which takes on all the latest features, and obviously also it takes on the bug fixes as well. Compilation. Compilation is tough. It feels, if you make a little mistake, the computer vomits back your software at you. And it's not easy because there are different compilers that we might try and compile with. We've got dependent software relating those two up there, parallelization. So you've got OpenMPI and Scotch, the only software with a tartan logo, despite being written by a Frenchman. And then you've got the visualization stuff, which is particularly difficult to get right. The problem is this interdependency of software, and the problem is versions, lots of different versions of stuff. So Henry and Will and so on and others are constantly testing combinations of versions. A new version of the compiler comes out. Does it compile? We have to test this. There's a lot of work goes into compilation, and particularly version stuff down on the power review end. It's tough. We have we package. So we package OpenFOAM. The default packaging is for Ubuntu. I think it's a sensible choice. We package the version 6, the development version, and PowerView, and they're available as packs. And I think why it's a sensible choice is because it works as is on Windows 10 using the Windows subsystem for Linux. We include it in a containerized system using Docker, so a container with the Ubuntu operating system and the installed software. And that software then can be used, or that containerized version can be used on other forms of Linux and on the Mac OS. And we have this happy picture of Windows and Mac OS holding hands while they're sat on by a penguin and its natural predator. So yeah, packaging. Releases are a lot of work. That they just provide a version which is a kind of a standard for everyone to kind of understand or adhere to, a standard in functionality, I guess, and actually in bug fixes as well. So release versions are important. All that software is accessible or available for download at this download site. So we maintain a download repository for the packaged software. We've got the license. So OpenFOAM is GPL3. We know that it gives us certain freedoms to modify the software and distribute it that we wouldn't otherwise have. There's sort of publishing related work for us to do there, that we have a contributor agreement for it, which enables us to enforce the license when it's broken. And why we do that, I think there's something the users can do, which is that if you receive a copy of OpenFOAM from somewhere, somebody, then just demand that all the source code is there. And that means the original and whatever modifications have been made. And actually, you should also be able to get a list of changes So that if you're saying, where has this all come from, you should be able to relate it back to some release from the foundation. You can do that, you can demand that. And if they don't do it, report it, and we'll try and follow up. We follow up with the bigger violations each year, and you might get, say, 2 a year currently. So it's important that we have our contributor agreement, because that makes following up on license infringements much easier to do. Documentation, or other resources. We've got the source guide, and we've got the website itself. And the website, you can get hold of the user guide. We maintain the user guide. If you want a ready-made system that can launch hardware running this packaged version of OpenFOAM, we provide a cloud version using Amazon Web Services, or one of our sponsors. So push-button platform that includes OpenFOAM and the underlying operating system software. So that's publishing, right? Code, compilation, packaging, download, licensing, documentation, cloud, promotion, last thing, that thing. So one other thing, promotion. You need to find out about all this stuff. And we write articles on websites, we announce stuff on social media almost daily. If you can't keep up with that, there's a newsletter that aggregates that information once a month so that you can consume it conveniently in one go. That's the last part of publishing. It's a lot of work. I think you'd kind of agree. The second critical work, repair. Things go wrong in software. We all know that. I think this is my HPC sysadmin guy. He can't install OpenFOAM, and so that's the look you get. This is my chemical engineer who's got to find a fault in some piece of equipment with CFD by tomorrow, and something fails in the code. You can imagine the reaction given the pressures of the job. This is the PhD guy. He's got to produce 30 graphs for a conference in 2 weeks' time, and some post-processing isn't working and the graphs aren't coming out. So we all experience this. We just need to stay calm and look at what's happening. And if we think that it's a fault with the code, which it very well could be, then someone will shout out, report it. So if you think it's a bug, report it. And everyone can do that. The users can do that. We have a bug reporting system that's been active since 2010. So you just go to bugs.openfoam.org. You can register an account. You only need the email address. And we keep that data private. We don't send marketing stuff or anything stupid like that. So it's only an email address. Enables you to report a bug. By the way, for the record, if you don't use the system for 2 years, we'll delete your email address. You can register again later, don't worry. And we get about 400 reports a year. So just to give you an idea of the level of issue reporting on the system. And we endeavour to fix those, and we do. Our record is clear on this. So you report a bug, it gets fixed, and the next one gets fixed. And then it might dawn on everyone that the fact that those bugs got fixed didn't benefit only the reporter of that bug, but they also benefited all of you. And in a way you might not even know. You didn't know that the bug was reported, and you didn't know it was fixed. So you've kind of reached the conclusion quite quickly that it's a good job there are lots of users and they're reporting bugs, because that's underpinning the reliability of the software that you're using. And if other people don't report those things, you might be using the software with bugs that you don't know about. And maybe miracles could happen and our sysadmin guy could decide he'll get involved in fixing the bugs as well. You never know. This is only any good if we actually fix the bugs, and the metric we can use to check our performance on that is just to count up the number of unresolved issues. Many of you have probably seen this graph. It's a very important graph. There are three distinct sections to it. The rising section, which predates the release of the development line publicly. So in that section there, OpenFOAM the development line was private. It only got unveiled on the users at the point of releases, and at that point, the users found all the bugs. Note the gradient change here. Oh, yeah. Following a release. That's because all the users suddenly find the bugs. So having a private development line is just a bad idea. So the smart ones amongst us thought we should release that publicly. That's Henry, actually. Henry decides, let's make it public. Admittedly, he wasn't working for 6 months because he had restrictive covenants from a contract. So he could devote all his time to fixing bugs. So that line is because Henry just fixed bugs every day for 6 months. And then reality came back where we had to earn a living, and so CFD Direct was founded. So the third part is the CFD Direct era of the bug story. The first part, that's the bit when I was saying I was attending a conference and worrying about the sustainability of the OpenFOAM. That was happening around about, say, 2014, and that's my concern illustrated right there. If we kept going on with that, the code would be unusable today. And so, you know, it's clear now, I think we've reached a point where we're more sustainable. There's still a story to tell at the end here. We'll come back to this. I would say period 3 shows what happens when developers are not weighed down by ill-formulated goals and stressful process friction. That's what's going on in that second part, where they've got the freedom to maintain and fix code, do redesign other aspects. That phrase I took comes from Eric Raymond in his quite famous book, Cathedral and the Bazaar, where he reveals the secret of Linux's success back in 1977 when it wasn't as successful as it is today. But one of his statements is release early, release often, and listen to your customers. And that's what we're doing. In a short sense, you say, we release OpenFOAM Dev and we fix reported issues. It's the same thing. That's the secret. So redesign. The last piece of work we do. Why do it? There's your 1970 Toyota Corolla and then the modern day equivalent. It's obviously been redesigned, and the reason is because you all want more features, greater comfort, increased capacity, while seeing improvements in reliability, efficiency, safety. Does it sound familiar? Same with software. And you want it at a reduced price. That car on the right, in modern day terms, is more than twice as expensive as the one on the left. So the price has come down. I don't know why that doesn't happen with software. The need for redesign, something Henry's going to talk about in detail. One thing is about managing complexity. That's the topic of his talk. And this graph just shows the number of code lines over the same period that we showed the graph for the unresolved issues. And you can see there are two eras, right? Two regimes. One is this one and one is that one. And this one, the number of code lines at some point looks almost like it's increasing exponentially. And I think Henry would argue because code is being duplicated, and when any functionality gets added, and the code just gets bigger and bigger and bigger, and there's never any redesign to consolidate the code. If you look in the CFD Direct era, we get a straight line. interesting, that's despite the fact that the amount of developments increased, certainly since the arrival of Will. So we've doubled arguably the number of developers that can do this work, but the line doesn't change because they're practicing redesign. And I think, you know, again, exponential growth in code lines, unsustainable, linear, in my view, sustainable. That's just representing the additional functionality that's going in the code. Redesign covers a lot of things I mentioned earlier. I'll give you a few examples and then we can finish up. So on the availability side, redesigning for availability, I'm going to pick out the compilation tools, so getting the closing Pandora's box there and getting that software back where it belongs. Huge amount of work by Henry to reduce number of open files, a request from the HPC community, clean up these platform-specific files, contain them in one place, get the compiler running efficiently in parallel, so getting it faster and faster running in parallel so we can compile the whole of OpenFOAM in not much more than 10 minutes, and then automating processes within the compilation tool. And compilation is part of availability, so this is redesigned for that area of that user need. Usability, I take more responsibility personally for that area. I'm conscious that the goal is for people to do effective CFD, and we need to define what that is. That people have the confidence to do CFD simulations, to produce reliable data, time and again, and that they do it in good time. Anyone can get that solution in 10 years, if you know. But everybody in reality is under time pressure. So we've got to work on making people more productive. We've done that. We've put in a huge number of new configuration tools in OpenFOAM involving redesigns. We've got tools that help you find things in OpenFOAM and learn about them. We've got templates and scripts to set up cases. The post-processing was completely rewritten to make it much quicker to set up. I think post-processing takes minutes when it used to take more like hours to set up. Scripts to start writing new code for boundary conditions, for applications, for post-processing. So it's all these tools which I think makes people more productive, and I fit those tools into what I call a process for doing CFD. Because we do training, I can see where we can redesign things to make people find OpenFOAM easier to use and quicker to use. I see it all the time. So we take what we get out of the training, we design the tools, and then we train those tools so that people have a process which I think gets faster and faster. My view is that you can set up CFD cases in OpenFOAM at least 3 times quicker than now in version 6 than we could in version 2. Which begs the question, why does anyone use version 2? It's got all those bugs and it's really difficult to use. Robustness. Let's go back to unresolved issues. There's a question that hasn't been answered here. Why don't we just fix those 50 issues? It seems easy enough. To get to the heart of that question, you've got to just analyze things a little bit further and say, what precisely do those 50 issues involve? When you do that, you find that there are clusters where we have problems, and that's the chart, and they're really in very narrow areas of OpenFOAM, like AMI, meshing admittedly a broader area, but thermal, so conjugate heat transfer, radiation, that kind of thing, clustered. Most of them are in that area. Will's going to talk later, for example, about redesigning AMI. He was the guy who redesigned particle tracking Lagrangian. So if you look at the same graph from 2 years ago, there was a whole extra piece of the pie which has now disappeared. And that shows that in order to overcome robustness issues, at times you've just got to redesign in order to change fundamentally that piece of code. So are the problems all gone with Lagrangian? Does Lagrangian need any more redesign? The tracking system says no, but when you start thinking about extensibility, then there's a problem. And the problem, again, that I'll talk more than me about, is that the way Lagrangian's designed is properties are attached to particles. So when you want to add another property, you've got to create a new particle. And that makes it harder to extend. I need to extend by creating more and more different types of particle. What I want to be able to do is just say, I've got this particle, I'll have a new property, I'll just add it in which case, you want, rather than attaching the properties to the particles, you just want to have more of a list of a field-based system where you just add another field, more like the continuum setup in OpenFOAM. So one thing, so decisions have to be made. We have to make decisions about redesigning Lagrangian, and the bug tracking system isn't giving us answers there because it says everything's okay. So we need decision making that goes beyond that. And so we'll come back to that later. We'll talk about the fact we need those decisions later. So that's it. At this stage, I've covered how we meet critical needs of users. And we've defined what the critical needs are: availability, usability, robustness, extensibility. And clearly, if there's that need, there's clearly work to be done, and it's critical work. And so, and that's the work. We've got to do redesign, repair, and publishing. So what we're going to do in the remainder of the talks this morning is give examples of that work in a bit more detail. So Henry's going to talk about managing the complexity of OpenFOAM via, I guess, largely redesign. Actually, Will's got a talk on redesigning OpenFOAM. We've got a case study from Francesco about developing OpenFOAM with redesign and repairing and publishing in mind, and the challenges that we face when we do that.